Okay, guys, let's review graphing linear functions before we get into our unit on systems. So recall that a linear function is simply a straight line on a graph. Slope-intercept form is a way that we write our linear equations so that we can graph them easily. So recall that the m in our equation, the coefficient of x, is the slope, how steep the line is. And we represent that with a ratio of rise over run. So it's the vertical distance compared to the horizontal distance between points. Then the b value is your y-intercept. It is an ordered pair where x is 0. This is also called the starting point. So if we were to graph an equation, we would typically start at the y-intercept. And then we would use our slope to find other points on our line. Here in our example, we have y equals 1 over 4x plus 1. Our slope is 1 over 4. We're going to go up 1 and then to the right 4 to get from point to point. And we will start at 0, 1. So your y-intercept is always when x is 0. So this ordered pair is 0, 1. Now we have a starting point to get to the next point going from left to right, just like you read a book, you read from left to right. We're going to go up 1 and over to the right, 1, 2, 3, 4. So this is a slope of 1 over 4. Let's take a look at a few examples and graph these together. First of all, we're going to notice that our equations are in slope-intercept form, y equals mx plus b. Now we can easily identify our slope of 1 over 2, and our y-intercept starts at -4. So we're going to start at 0, -4, and then we're going to use slope to find a few other points. Our slope is rise 1 and to the right 2. So up 1 and right 2, up 1 and right 2. Now, if we wanted to, we could see what the graph looks like on the left side of our y-axis. Instead of going up 1 and right 2, we could go down 1 and left 2, down 1 and left 2. So you can see the points are still lined up with the other points, creating our linear function. This one has a positive slope. It slopes upward when we go from left to right. Now let's take a look at a second example. And this time, our slope is negative. So instead of going up, we're going to go down 3 and to the right 2. And we're going to start at 0, 7. So our starting point is 0, 7. And then to find a few other points, we're going to use the slope. We're going to go down 1, 2, 3, and to the right 2. Down 1, 2, 3, and to the right 2. Again, if we wanted to go back to the initial value, and instead of going down and right, we could go up and left. So up 1, 2, 3, and to the left 1, 2. And again, that point lines up with our other points. So this slope is negative, therefore our line is going downhill. Another example, y equals -x plus 3. So our slope is the coefficient of x. So this is an understood -1. And then anytime I have an integer, I can write it as a ratio by putting 1 in the denominator. So this slope is -1 over 1, and we start at 0, 3. So we're going to start at 0, 3. We're going to go down 1 and right 1, down 1, right 1. We could also go up 1, left 1, up 1, left 1. And we have a negative slope, so our line is going downhill from left to right. In this example, we have y equals x, Again, your slope is the coefficient of x, so I can write in the 1, and then we put it over 1. There's no b value, so this is really like plus 0. So we're going to start at 0, 0, which is the origin. And our slope is up 1, right 1, up 1, right 1, or down 1, left 1. And then we draw our line all the way through, nice and neat with arrows on the end. Y equals 5. Y equals mx plus b. We notice there's no x. So this means this originally was y equals 0, a slope of 0 times x plus the 5. And 0 times anything is nothing. So that's why there's no x here. So this line is the line that has a slope that is 0, meaning it's not going up or down. It's just going straight across horizontally. So our slope is 0. And we do have a y-intercept of 0, 5. So we're going to start at 0, 5, and then we just have the horizontal line going through the 5 on the y-axis. So when you have y equals some number and there's no x, remember it passes through the y-axis at that number. Now let's take a look when we have x equals a number. There's no y involved. This time we have the vertical line, and that means it goes up and down, and it goes through the x-axis at -2. So we have this vertical line, which is our only linear function that is not a function. I shouldn't say linear function. This line is the only straight line that's not a function. It doesn't pass the vertical line test. It has a slope, and we call it undefined. And notice it doesn't go through the y-axis at all. So you can put NA or you can put null. There is no y-intercept. So remember, when you have x equals some number, it does pass through the x-axis at that given value. And I hope this helps.